this video, I'm going to focus on graphing reflections of the x and y axis of logarithmic functions. Again, we're going to do the same thing where you write the transformations, right, in order from left to right, and then graph the parent function, then apply each of the transformations in the stated order, and that will help you to graph. So let's try this first example here. We have f of x equals negative log base 2 of x minus 4 minus 2. So my parent function that I'm looking at is really log base 2 of x. Now if you're having trouble with that, you can always graph the inverse, which is 2 to the x, and then reflect it across the y equals x line. Okay, so it's just depending on where you are in that process. So hopefully at this point you may be able to graph log base 2 of x directly on your own. So log base 2 of x, I know, is here, and then here, and then at 4, I'm at positive 2, and then here. Okay, so that is my parent function, log base 2 of x. Now the negative in front means it's a reflection in the x-axis. X-axis. Then inside the negative 4 means it moves to the right 4. Negative 2 means down 2. So since we have our parent, log base 2 of x, then we're going to go ahead and do the reflection in the x-axis. So the x-axis is here, right? And remember that our vertical asymptote is here. Cannot ever have 0 or negative in the log, so x equals 0. That's the parent. And so what we're going to do is reflection in the x-axis. So we're reflecting across this line. So we notice at this point right here, the 1, 0 doesn't change. So I'm going to keep that the same. And then everything else is going to reflect across it. So this point will be on top. This will be on bottom, the same distance from the x-axis. Okay, so apply that first here. Okay, so that's my reflection in the x-axis. Next, I'm going to move everything right 4 down 2. So I'm going to take each of these points, right, move it right 4 and down 2. Down 2. Okay, so that's my next point there. So that is at 5, comma, negative 2. Okay, so just kind of getting those points. Then moving each and every one. So, or just kind of copying the dots, right? It's up to you, however you see it. Here, right 4. Down 2 is here, and then that last point is there. Okay, so that is, this one is 8, comma, negative 4. We have negative 5, negative 2. This is negative 6, negative 3. I'm sorry, positive 6, negative 3, excuse me. 1, 2, 3, 4. And this is 4.5, comma, negative 1. Okay, now we also have to move our vertical asymptote because it shifted to the right 4. So remember, I have to plug in numbers larger than 4, so that kind of helps you with the domain as well. So therefore, my asymptote is x equals a positive 4, and then I can finish out my curve. So it goes like this. Okay, and then so let's talk about domain. Our domain is from 4 to infinity. Our range is negative infinity to infinity. So that's a reflection in the x-axis. So let's try a reflection in the y-axis. So again, we're going to use log base 2 of x. Okay, again, you can graph the exponential 2 to the x, and then just, you know, switch the roles of x and y, and those will get you your the log. Right, so then the x would be here and the y would be here. All right, so log base 2 of x, I'm going to graph that first. Okay. And then, oh, I could even have this one as well if I wanted another point, 3, 8. So let's describe the transformations. Negative means a reflection, negative with the x inside, reflection in the y-axis. Y-axis, and then what makes a 0 inside? That's going to be a negative 3, so therefore it's a left 3 and then an up 4, right? Again, you can look at this, factor out the negative, and so you see if I plug in a negative 3, so it's left 3, would make that a 0. All right, so remember that our vertical asymptote is here. And so that's going to shift left 3, right? So we know that for sure. We can do that first. It's up to you, just to make sure you don't cross it. All right. Now let's do the reflection in the y-axis. So reflection in the y-axis, you're going to take this point. Let's ignore this for right now. We're going to reflect it across the y-axis here, so it's going to flip to the other side here. Okay, so that changes. So, just kind of think about what you're doing, applying the transformations one by one. So it reflects in the y-axis. That means it's here. Same distance from the y-axis there. So this is next. And then this point here, and here, and here. So we reflected it. So that pink is now the log base 2 of negative x, right? So you can only plug in negative values in order for that to work. So it makes sense that it's on that side of the asymptote. Now we're going to take each of those pink points and move it left 3, up 4. So I'll take this one left 1, 2, 3, up 1, 2, 3, 4. So we find that that point is at negative 4, positive 4. Okay, and I keep on going with that, or I can, if I know the general shape of my other one, so that's the other thing you could do. I know that next point is like down, right this far and down that far, right? Down 1. And then this next point is up 1, right 1, up 1, right 2, to kind of help you out. So it's up to you. However you see it, move each and every point one by one, left 3, up 4, or, or kind of copy the shape so that way it retains the shape. So if we label these points, I really labeled negative 4, 4, and then the next one is 1, 2, 3, negative 3.5, 3, and then this point here is 1, 2, 3, 4, negative 5, and then positive 5 there, and then here is the graph. Our domain is from, in this case, it's negative infinity to negative 3, right? I can only plug in values that are less than negative 3 for this to work. And the range is still negative infinity to infinity. I can have all y values there. Okay, so I hope that kind of helps you out. I do have 2 examples for you to try for graphing reflections of log. And so those examples are here. So if you can go ahead and pause the video and see if you can do these on your own. All right, if you tried it out, these are the graphs that you should get. Oh, let me go ahead and fill that graph in. Sorry about that. There we go. And so I'm hoping this kind of helps you with your graphing of transformations, right? So graph the parents, do the transformations one by one. So reflections in this case will come first, and then apply the left and right last.